What's up, math fans? You ever think about, you should be thinking about going to college, right? When you go to college, there's factors that come into play when you make your decision. You know, how far is it? What are the majors there? What kind of people go there? How are the teachers? Stuff like that. So whenever you make a decision, there's a lot of factors that weigh into creating that decision. Well, same thing in math. When you're factoring, you're thinking about all those things that created, in this case, a number. So if I want to factor 24, I want to know what created the 24. Where did the 24 come from? What were the numbers that decided in creating or making a 24? So basically, factoring is a fancy word for dividing. So I want to think about my factors of 24. And there's a couple of ways to do it. One is you just think of all the numbers that go into 24. Start with 1, yes. 2, yes. 3, I'm not sure. Let me get a calculator. Or here's a trick. If you want to know if a number is divisible by 3, add the digits together. 4 plus 2, 4, 5, 6. That number 6 is definitely divisible by 3. Therefore, 24 is also divisible by 3. So my factors would be 1, 2, 3. Does 4 go into 24? Yes. 5, no. 6, yes. 7, no. 8, yes. 9, no. 10, no. 11, no. 12, yes. And then I'm going to skip all the way to 24. And I had a plan when I did this. It wasn't just random. My plan was, once I knew 1 goes into 24, it has a factor pair of its pair is 24. Once I know 2 went into 24, I knew it must have had a pair, a partner, and that was 12. 3 had its partner 8, and then 4 had a partner 6. So all my factors come in pairs. Something times something gives me 24. There's a reason I'm explaining this, even though this is very old and you learned this a long time ago. Here I have 1, 2, 3, 4 little pink rainbows, four loops, 4 factor pairs. It's an even number of pairs. That's cool to know. But I'm going to do this differently. When I do my 24, I'm not going to think about all the factor pairs. I'm going to do it the easiest way I can do it, which is to think of the first factor pair. Doesn't matter. Pick your favorite factor pair, and we're going to make a factor tree. Naturally, people seem to think about 2 for some reason. So I'll do it. 2 and 12. 2 times 12 is 24. Now, 2 is a prime number, so I'm going to leave it alone. It doesn't have a factor pair. Well, it does 1 and 2, but that would just repeat the 2 again, and there's no use in that. So a prime number is a number that's only factor pair is 1 in itself. So once you get to a prime number, you can stop. I'm going to show you that I stopped by underlining the 2. But 12 keeps going. That's 2 and 6. And then 2 again, so I can stop there. But 6 keeps going. That's 2 and 3. And now I'm done. So I've got what I could consider a prime factorization. And back in 3rd grade, you might have rewritten it as 2 times 2 times 2 times 3. Also known as 2 to the 3rd power times 3. Some people do that. 2 times 2 times 2 times 3. This is my prime factorization of what built the 24. All right? So this is an introduction to factoring, factor trees, factor pairs. Now you know what prime numbers are. If a number is prime, its only factors are 1 in itself. If a number is composite, it has more than just 2 factors. It has 1 itself and other stuff. So these pink underlying numbers, all these numbers are prime, but the original number was composite. All right, let's go to 36. I'm thinking 2 and something. You get a calculator, you'll figure it out. But actually, I want to show you that 2 shouldn't have to be your go-to number. You can pick any number you want. I'm actually thinking about 9 times 4 is 36. And then 9, that's 3 times 3. And 4, that's 2 times 2. And I am now done. Those are my prime factors. What's interesting about this is the 3 shows up twice, the 2 shows up twice. Factor pairs. I'm going to go back to factor pairs now. Okay, so there's your factor tree, there's your prime factors. You got me? Now I'm going to restart the 36. What if I decided to just list the factor pairs of 36? For example, 1, then what? 2, then 3, then 4, no 5, definitely 6, no 7, no 8, no 9, yes 9, no 10, no 11, yes 12. Can I skip ahead now to 18? And then of course 36. So check this out. 1 and 36, that's a pair. 2 and 18, that's a pair. 3 and 12, that's a pair. 4 and 9, that's a pair. How come 6 doesn't have a pair? 6 is all alone with no pair because 6 times itself is 36. So now I got myself a perfect square. A perfect square is a composite number where it has an 1, 2, 3, 4, an odd number of, it has, doesn't matter how many factor pairs it has, but it has one number that kind of sticks out that doesn't have a second pair. It has itself. A perfect square has a factor that times itself gives you that number back. For example, 9, right? Because 3 times itself doesn't have a pair. It is its own pair. So these are perfect squares. 9, 100 is a perfect square. 36. Think about all your favorite perfect squares. Write them down. All right? Let's move on. Finally, we get to the hard stuff. Here, based on what we just did, I'm not going to do the factor pairs. I'm going to just ask you to do prime factorization, meaning make a factor tree. So here's my tree. Wait a minute, what do you got variables doing here? Don't worry. Hide the variables, do the 18. 18, 9 times 2. 2, stop. But 9 is 3 times 3. Look at that. Same number means 9 was a perfect square. So I got my 3, my 2, my 3, my 3, and my 2. But x to the third, I want to break that down too. So that is actually going to break down as x times x times x. And y squared, I want to write as y times y. So my final answer would be 3 times 3 times 2 times x times x times y times y times x times x times x times y times y. All right? This is called writing it in factored form. Factored form, factored form. I think I said that enough. We're good? That is factored form using a factor tree. Now you use that knowledge to actually factor stuff. So check this out. They're going to give you a binomial or a trinomial, it doesn't matter. They're going to say factor this thing by finding the GCF. So in your mind, you're going to do the factor tree of 4x. My mind happens to be the whiteboard. That's 2 times 2 times x. Okay? In my mind, I'm also going to factor 6, which is 3 times 2. So my greatest common factor is whatever I see in both. I see a 2 here, I see a 2 here, so I'm going to write 2. My greatest common factor is 2. But that's not enough work, so now we're going to put parentheses. You got to figure out, if I factored a 2 from the 4x, what's left? That 2 is out, what's left is the 2x. 2x goes inside. If I factored a 2 from the 6, what's left? 3. So this is going to say, instead of plus 6, it's going to say plus 3. This is your factored form. Okay, this is considered a factored form. And that's a very popular question in algebra, is how to factor. So they give you this, they give you this, they ask you to factor. Here's your answer. And if you're not sure, you check by doing your favorite property, the distributive property. 2 times 2x is 4x, 2 times 3 is 6. Look at that, same answer, so we're good. All right, thanks for paying attention. I think you're a master at it now. I'm gonna do this one. You can try it on your own first, so pause and unpause. Let's see. I'm gonna do 18x squared y to the third minus 12x squared y. What goes into both? What goes into both 18 and 12? My GCF is going to be 6. What goes into both x squared and x squared? Oh, that's easy. X squared. What goes into both y to the third and y? That's a y. And then we got to figure out what goes inside. All right. Hopefully 6 times what gives me 18. You'll figure it out. But I'm going to show you how to figure it out foolproof without killing yourself. You just show your work. So check this out. I'm going to write my 18, x squared y to the third, and I'm going to break it down. So 18 is really 9 times 2. X squared is x times y times y times y. 9 we said was 3 times 3. Now I'm going to do the same thing for 12x squared y. 12x squared y. That's 6 times 2 times x times y, which is 3 times 2 times x times y. Alright? What's in common? There's a 3 here, there's a 3 here. There's a 3 here, nope. There's a 2 here, yep. There's a 2 there. So I have a 3 and a 2 in common. That's a 3 and a 2 in common, and that's where I got my 6 from. Now I have an x here, I have an x here. I have another x, I have another x. That's why I have x squared. What else? I have a y here and a y here. No more y's, so that's it. That's why this is my GCF. Now you got to figure out what's left. So what did I not circle? There's a 3 and a couple of y's. So that's 3y squared. Minus sign, minus sign. What else didn't get circled? There's 2. Anything else? No, just a 2. And there you have factored form. All right, thanks for watching. See ya.